probably I will announce the following talk in English because its name in English, and it will be Irina Alexeyevna Sekerina and Glenn Stark, and the talk is called "What Matters in Processing of Scrambling: Cross-Populational Investigation in Russian." Please.
Так вы же сказали, подождем до 10:15, сейчас только 10:14. Может, подождем одну минуточку?
Ну, давайте еще подождем, да.
Хорошо.
На моих часах 17:15.
Хорошо. Я бы хотела просто сначала сказать слова благодарности светлой памяти Александра Евгеньевича Кибрика, без которого бы моя карьера не состоялась. И я помню все его моральную и физическую поддержку, потому что даже самые свои первые эксперименты я проводила в его кабинете. Now, I will do it in English just because it's much faster for me than to do it in Russian. But of course, I can answer questions in both languages. Oh, 1 second. For whatever reason, it doesn't want to move. Okay, some technical issues. Maybe I stop sharing for a second, fix it, and come back to you.
We have some technical problems, so we're waiting for...
That's right, some technical problems. Here we go. Okay, it works now. Okay, so this is a short map of the talk. So in the present study, I would like to focus on 2 experimental groups. One of them is known as heritage speakers. In this case, it's going to be heritage Russian, English bilingual young adults, and monolingual children, in comparison to monolingual Russian adults, which we refer to as baseline speakers. In case some of you don't know who heritage speakers are, these are young people who grew up in a family that spoke Russian, either because the family immigrated to the United States, in my case, from Russia, or because they were born in such families. So what happens in these situations, these speakers learn to speak Russian as their family minority language known as heritage language. And the actual subject matter of the talk is scrambling, or word order variation, which in psycholinguistics is known as Philly gap dependency. So here you can see very simple examples that were used in the experiment. So the canonical structure on the left is SVO, корова везет лошадку. The scrambled, non-canonical structure, OVS, is корову везет лошадка. Young children acquiring the first language and heritage bilingual adults are characterized by a high degree of individual variation. However, when compared to monolingual or baseline adults, there are often systematic similarities among the 3 groups. So for example, children but not heritage adult speakers pattern with baseline adults, heritage speakers but not children pattern with baseline adults, or for example, both children and heritage speakers differ from baseline adults. Polinsky and contrast in the 2020 keynote article in Bilingualism, Language and Cognition suggested that similarities and differences among the 3 groups depend on the linguistic domain and are especially evident in language comprehension compared to production. Comprehension of many syntactic phenomena, such as WH questions, for example, remains target-like in heritage speakers and children. However, that of many morphosyntactic features, such as gender agreement, and case, are often full of errors. In this case, heritage speakers are not like baseline adults. In this current study, I will present the results of the visual world paradigm, where we recorded people's eye movements when they processed short scrambled OVS sentences in comparison to canonical sentences in these three groups of Russian participants. So baseline adults, control, and two experimental groups, 5 to 7-year-old children and heritage bilingual adults. So what do we know about scrambling in general? In the field of adult psycholinguistics, we have found empirical evidence for psychological reality of fill gap dependencies. While many behavioral studies found cost associated with filling in the gap for WH movement, findings for scrambling are mixed. Some behavioral results for monolingual adults, especially comprehension accuracy and reading times in self-paced reading and eye movements, showed that canonical SVO transitive sentences and sentences with one scrambled argument, like OSV, for example, are processed equally easy, while others did not find the same results. So processing difficulty in monolingual adults often emerges in ditransitive sentences with two scrambled arguments, especially when the length of linear distance between the fill and the gap is larger. There's also electrophysiological and neuroimaging studies that have demonstrated that there are brain related differences between canonical and non-canonical scrambled orders. But in behavioral measures, it's not always that easy to find the difference. But children, as far as we know, can actually produce scrambled sentences as early as between the ages of 2 and 4. But despite that, in comprehension, difficulties in understanding scrambled sentences in tasks such as act out or sentence picture matching can actually continue into the elementary years. And we don't know that much about processing of scrambling in L2 learners, but there are a couple of papers. For example, Hera 2011 showed that Korean learners of Japanese, actually both are scrambled languages, were slower in processing in sentences in scrambled condition, but it was only happening under the conditions of moderate processing load. Now, the most frequent cause for the problems in scrambled sentences for children and L2 learners has to do with the fact that they look like passives, and we know that these two groups have problems in processing passives. And this is a conflict between the word order and agents as subjects processing bias and thematic role assignment. That is, the object, right, patience, precedes the subject, agent, and it's sometimes difficult for these two groups to overcome these difficulties when cognitive resources are limited. In children, they're limited because they're still developing, and in L2 adults, it's because high processing load is associated with a weaker language. Now, interestingly, we know that in scrambling sentences, we actually have case in many languages. In this case, the scrambled object is marked with the accusative case. So that idea, one should think that this should help. So reliance on such morphosyntactic cues as case is especially critical for processing of reversible scrambled sentences like "Корова везет лошадка," because in this case, both the object and the subject are animate, and each of them can be either patient or an agent. Now, do these morphosyntactic cues help processing scrambled sentences? Well, we know that it's not usually the case. It turns out that the case cue is not sufficient enough, especially in languages that have been investigated with children like Japanese and Turkish. So children's ability to use case to correctly comprehend scrambled sentences has to be backed up by other cues like word order. So here's a very interesting example that comes from work by Özge and her team on German. A German case is marked on the pronominal determiners, and it allows the object to be scrambled above the subject. Another group of colleagues who studied processing of German scrambled sentences in children demonstrated that many children until the age of 7 still do not comprehend scrambled German sentences correctly. So in Schipke's work, the accuracy is about 60%. Now, Özge and her team showed that actually 4- and 5-year-old German children can process these sentences correctly, and they showed that in the visual world paradigm study where they demonstrated that children could launch eye movements to the subject while they were still on the verb. So they haven't heard the subject yet, but they could only infer it from knowing that this is a scrambled word order. They also showed very similar pattern in Turkish, and this last paper is published in Cognition. Now, coming to Russian, it's easy for me in this audience. We know that Russian is a relatively free word order language that has considerable flexibility in the arrangement of arguments and adjuncts. And of course, we have case paradigm. In the recent study by Makarchuk and Slusar, they looked at the Taiga corpus that has 92 million tokens in the news section and 82 in social media. They evaluated 875,000 transitive sentences, the ones that I'm interested in. And of course, they found that SVO was the predominant word order, but you can see from the table that OVS is also quite common. Of course, not as common as SVO, but common nonetheless. Now, we have a couple of earlier studies, including my own, that looked at the question of whether monolingual Russian adults experience a slowdown when they read monoclausal scrambled sentences. Both Natalia Slusari and I used the self-paced reading in those experiments, and we we contrasted sentences with two arguments, direct object and indirect object, that were either scrambled or in their canonical word order after the verb. And what I found in my work, that total reading times were longer for scrambled sentences than for sentences in the canonical word order, but this effect was moderated by context. And Slusar, later in her work, in her dissertation, found that reaction times for canonical and scrambled word orders did not actually differ, again, when the context appropriately prepared the readers to experience the latter. So in this current study that I'm moving on to right now, we try to look and answer 3 questions. So we looked at comprehension of scrambled and canonical sentences in these 3 groups. We were interested whether they exhibit sensitivity to case and word order cues, and whether, following the Özge's group results, whether they can actually predict syntactic structure of scrambled sentences online. Yes, thank you. All right. There was also actually a bunch of experiments that have been done with Russian children recently that showed that production of accusative case in Russian children is at ceiling already by the age of 3. But again, usually this is tested in canonical word order sentences. So I'll come back to that. So in the experiment that I'm describing now, we use the following materials represented here. You can see the one of the pictures that was used in the experiment, and the picture is on the left. There was only one picture on the screen at any time. So in the picture on the left, participants would see these 2 animals, and they would hear a sentence, коровка, корова, везет лошадку, right? Or they would see the second condition, which is a scrambled sentence, корову везет лошадка. To make sure that we don't get the yes bias, which is well known for younger children, we made sure that all experimental items required the answer yes. So this was a sentence picture matching task with the single picture on the screen. The participants are on the left. We had a control group of 16 monolingual adults. We didn't need more than that because this is a very simple experiment. We had 28 monolingual Russian children between the ages of 5 and almost 7, and matched for age heritage speakers group that was recruited in New York, and there were 21 of them. And of course, the experimental sentences were interspersed with fillers to make sure that people don't get what the experiment is all about. And the fillers included all kinds of constructions in them. So let's first look at at one type of the results, which is accuracy. So whether the 3 groups of participants performed accurately in matching the sentence to the picture. So it's a picture matching task. So you can see on the right, the 2 bars. They're not real bars because these are monolingual adults who performed at ceiling with one exception, which is always happens. So they were at ceiling at approximately 99.4% correct. The next 2 in the middle are heritage language speakers. They're called bilinguals in the graph. As you can see, SVO word order was also at ceiling, while OVS sentences were processed in the range. That is, there were people who were doing it at ceiling and people who were doing it at chance, giving us on average 84% accuracy in the processing of OVS sentences. And the 2 left bars are children, and as you can see, there are errors both in SVO and OVS. So statistical analysis demonstrated the effect of group, where monolingual adults were significantly more accurate than heritage language speakers, and heritage language speakers were significantly more accurate than children. If we look at pairwise comparisons, there was an effect of word order in the heritage speaker groups. That is, the SVO was processed significantly better than OVS. And this difference between SVO and OVS accuracy in children did not reach significance. So they were basically, statistically speaking, the same in processing both word orders. Now, we also decided to make sure that there are no effects of, well, to find out if there are any effects of age, both for children. Obviously we had children from 5 to 7, and age of arrival for heritage speakers. Now, for children, there was nothing. There was no correlation between accuracy and age. But for heritage language speakers, there was a strong correlation between the age of arrival and accuracy. So those who arrived after the age of 7 did quite better than those who arrived before the age of 7. Our final analysis was eye movements. So here at these graphs, you see 2 lines. The red line represents eye movements in the SVO condition. That's the canonical word order. And the blue line is the OVS condition. Now, what's plotted on the y-axis, excuse me, is the difference in looks between the agent and the patient, what we call agent advantage. So if you look at the photo on the left, you will see that during N1, which is either subject or object, there isn't much happening because the looks are all at about 0. 0 means neither agent nor patient attracts more looks. However, when we move into the verb region, that is везет, so somewhere in the middle, and to be precise, at 567 milliseconds after the onset of the verb, and 0 is the onset of the verb, monolingual baseline adults started looking at the correct N2, whatever this N2 will be. So there is a divergence point in the looks showing us that they can predict what's going to happen next without hearing that word yet. Now, if you compare the picture on the left with the picture on the right represents eye movements of heritage speakers, you can see that they are almost the same As adults, this difference of 467 millisecond divergence point is not statistically significant. So despite the fact that heritage speakers are not so accurate in OVS, they seem to be able to process it in terms of their looks. Now we compare that to looks in children. So the picture on the right is the same one that was on the previous slide. The picture on the left is children. As you can see, there is no divergent point, sort of representing the fact that in their accuracy, children were almost the same for SVO and OVS. The stuff starts happening with them way beyond 2000 milliseconds. That's where the graphs are kept on the slide. And this is just a little bit of statistics for you in case you want to know how it was done. We used the bootstrap analysis. Okay, coming back to the three questions. This is a little comparison of accuracy data with recent studies with children. As you can see, the three studies that were done just recently on comprehension of sentences with different cases, all three of them used, including one of my own studies, used a two-sentence picture matching or selection. So you have two pictures now, and you have to match the sentence to one of them. Now remember, in this study, there was only one picture. Now, but you can see that the accuracy results are pretty much similar in all four studies. So what we can say that our results confirm previous research on accuracy of comprehension. Both conditions were processed above chance. There was no difference between the two. But for heritage speakers, which are not included in the table because these are children, OVS was processed in terms of accuracy much harder, much worse, more like what children did. Coming back to the second question, yes, we found that children and heritage speakers are sensitive to case, as demonstrated by their sort of average above chance performance in the OVS condition. However, there was a huge individual variation in both groups. So here's some of the data. There were 7 children who were 100% accurate at SVO, and only 4 were accurate at OVS. So there was a trend for improvement with age. That is, as children get older, the accuracy increases. Nothing surprising here. Now, for heritage speakers, we're actually 9, almost half, that were at 100% correct at both SVO and OVS. But again, remember, there was a significant correlation for age. Now, finally, to the third question, whether they could actually use case predictively. I'm just comparing here the results of my previous study with Natalia Mitrofanova, where we used both experiments used children. We used 2 pictures. And as you can see, so for example, picture on the left is пушистого зайчика сейчас съест лиса. And now you can see that in the figure below that, children can use case markings predictively and figure out that this is the non-canonical order. In this experiment, that didn't happen, but the method was quite different. So I think a final conclusion is that the complete theory of processing of scrambling across different populations must include extralinguistic and developmental factors, for example, age and age of arrival for heritage speakers, methodology for children, but not necessarily for heritage speakers, and heritage speakers' proficiency. And that's it. Спасибо.
Thank you very much. So now we can discuss the talk. Please, if you have any questions.
И можно не обязательно по-английски задавать, можно и по-русски.
Да, можно я тогда по-русски уточню?
Да, пожалуйста.
Вот почему всегда ответы на вопросы должны быть утвердительными?
При работе с детьми, когда детям дается возможность ответить на вопрос, выбрать картинку, что-то сделать, где им нужно сказать «да» или «нет», существует когнитивное предпочтение, особенно у маленьких детей, всегда говорить «да», потому что они не любят возражать взрослым. Это называется confirmation bias, or yes bias. И поэтому в тех случаях, когда мы даем возможность детям сказать «да» или «нет», то, возможно, они понимают, что нужно сказать «нет». Но вот это социальный навык говорить «да» может помешать им сказать «нет». Поэтому в этих случаях мы делаем филлеры такими предложениями, где можно сказать «нет», а все экспериментальные предложения оставляем так, чтобы на них можно было ответить «да». Конечно, у взрослых этого нет, и у детей это начинает исчезать в районе 4-4,5 лет. Но до этого.
Понятно.
Я тоже вот как раз, во-первых, Ир, очень рада вас видеть.
Михайловна, я взаимно. Сколько лет?
Да, спасибо за доклад. И я тоже вот хотела получше понять, значит, всегда подпись картинки соответствовала или не всегда?
Вот в нашем эксперименте, вот
да,
наше
да, вот
экспериментальное предложение,
ага.
Участники и детишки видели только одну картинку.
Я понимаю. А подпись под ней соответствовала тому,
да.
что... Да.
Для экспериментального предложения всегда да. То есть вот в этом случае картинка 1. Они всегда слышали «корова везет лошадку». Или они слышали «лошадку везет корова». То есть не было никогда такой ситуации, чтобы то, что они слышали, то, что они видели, друг другу противоречили. Да, потому что для детей это принципиально.
Ясно. Спасибо.
Пожалуйста, еще вопросы? Можно я тогда еще уточняющий вопрос про графики?
Про графики, пожалуйста.
Да, про графики я вот как-то не очень уловила вот другие, да, вот эти графики. Вот возрастание и убывание графика.
Ну, давайте попробуем, сколько у нас есть, все 4 минуты, если никто не задаст еще вопрос. Давайте просто посмотрим на то, что происходит, когда человек, пусть будут монолингвы, неважно, слышит предложение. Вот посмотрите на красную линию, значит, N1 в красной линии – это корова. Значит, вот они слышат «корова», и в данном случае их движение глаз вы видите примерно 10% над нулем. Это означает, что они немножко больше смотрят на корову. Как только они дошли до глагола, то есть они слышат «корова», «ве», и как только они слышат «везет», они уже знают, что должен быть пациенс, должно быть прямое дополнение. Поэтому с нуля красная линия уползает ниже нуля. То есть теперь они начинают смотреть на пациенса, они начинают смотреть на лошадку. То есть они ее уже предугадывают. Хотя лошадка начинается вот только здесь. Но уже видно, что практически после 1/3 прослушивания «ве» они знают, что так случится. Теперь, если мы посмотрим на OVS, это значит синяя полосочка, да, здесь то же самое. Вначале ничего не происходит, примерно одинаковое количество движений глаз в данном случае будет на ту же самую корову, но предложение здесь другое. Лошадку везет корова. Дальше они слышат «везет», и теперь они переключаются на подлежащее, да, потому что лошадку везет корова. Они слово «корова» еще не слышали, но они уже на слово, поскольку они услышали «падеж», да, лошадку везет, они переключаются на корову. И вот тот факт, что вот это разделение движений глаз происходит до момента того, как они услышат прямое дополнение, показывает о том, что, как и предполагалось, они знают, что ожидать, что нужно ожидать пациента, что нужно ожидать в данном случае. Здесь нужно ожидать подлежащее, а здесь нужно ожидать прямое дополнение. И у наследников, у heritage speakers, картина примерно такая же, немножко с точки зрения абсолютных цифр, это немножко другое, но вполне похожее. А у детей этого нет совсем. То есть они продолжают в любой точке. Вот тут есть немножко разница, но она очень короткое, не очень понятно, что она означает. Видно, что вот на глаголе у детей не происходит никакого разделения в SVO и в OVS. Разделение происходит значительно дальше, в районе 3 секунд, где уже предложение давно закончилось. То есть, конечно, они понимают, о чем идет речь, просто они не могут это сделать так быстро и так эффективно, как взрослые, даже взрослые наследники.
Понятно.
Теперь понятно, да?
Да, теперь понятно. Спасибо.
Пожалуйста, пожалуйста.
Так, ну, еще, в принципе, один коротенький вопрос.
Да, пожалуйста, с
Если у
радостью.
кого-то есть. Или если вопросов больше нет, тогда еще раз спасибо большое за доклад, за все
Пожалуйста.
пояснения. Все теперь стало понятно.